Hi grade 8s, welcome back to another video lesson. So today we're going to continue with solving equations on page 85. Alright, so to solve equations, you saw in the previous examples that we took terms to the left and right and we tried to isolate variables on one side, numbers on the other, and try to get rid of brackets and so on. So there's a little checklist that you can follow for yourselves in what order you're going to be, how you're going to be solving the equations, okay? So the checklist is on the top of page 85 and I'm going to quickly go through it, right? To solve equations, follow these steps. Number one, multiply out any brackets and add any like terms together. So we got the left-hand side, the right-hand side of an equation and equals in the middle. So on each side, you're going to look at each side and multiply out the brackets. In the next step, you're going to see if there's any like terms that you can add together. So that is our step one. Step 2, isolate the variable term by adding the additive inverse of the constant to both sides of the equation. Okay, so what this is saying is that, let's say we have x plus 2 equals to 1. Okay, what they want to do, what they're basically saying in step 2 is that we want to isolate the variable, which is x, and we want to keep it on one side of the equation. Okay, so we want to isolate that. Then they're saying we want to add an additive inverse to both sides of the equation as to get rid of the constant term. Remember, an additive inverse is a number which is the same number that we have. Let's say we have a number 5. An additive inverse to number 5 would be negative 5. So that when we add them together, we get 0, meaning we get rid of that number on a particular side. So what they're trying to tell us is that, well, we need to get rid of this positive 2 because we want x on its own. So remember, we do it by taking it to the other side, but this is the same thing. This is more or less like the explanation behind it. So what we're doing is we're adding an additive inverse to each side. So here, an additive inverse of positive 2 is negative 2. So we have x plus 2 minus 2 equals 1. But whatever we do to the left, we must do to the right. So we got to subtract the 2 from here as well. Okay. So do you see what happens? This 2 minus 2 disappears and becomes a 0. So essentially we have x equals 1 minus 2. Now, you can do it that way. There's no problem of adding two terms on both sides and working through it. But there's a quicker way so that you don't have to waste the step where they cancel out to give you 0. So for the first few, you can do that. But then what I want you to think of is that this positive 2, if we want to take it across, it crosses the equal sign and becomes a negative. Look exactly what happened. We took the positive 2 from here. It went over the equal sign and became a negative. Okay, so that's just another way of thinking about it. So I like to take things over the equal sign, and all I know is that, or not all I know, but I know that it changes sign as it crosses over. Okay, it's up to you which way you want to think about it, but it's really the same thing. So here x will equal 1 minus 2, which is minus 1. All right, so that was just an example. Right, so step 1, multiply at brackets, add like terms together. Step 2, take the constants to the other side by adding the additive inverse. And the same thing applies to the variables. If you want to take a variable to the other side, it will change sign just like the numbers. Okay, cool. Step 3, divide both sides of the equation by the coefficient of the variable term. So what they're saying here is that once we've taken things left and right, and let's say we get 3x equals to 6, okay? We've multiplied everything out, we took numbers to the left, variables to the right, and this is where we get. Now they're saying that we need to divide both sides by the coefficient of x. Remember, the coefficient is a number in front of the variable, and it also has that sign, okay? So here the coefficient is positive, okay? So they say divide by the coefficient of x on both sides. And that's what we've done. So this 3 will cancel with that 3, leaving us with an x. And this will equal 6 over 3, which is just 2. All right, that is step 3. And step 4, check your answer. Okay, the way we check our answer is like this, right? So let's say we have an equation that says 2x plus 1 equals to 3. Okay, and let's solve this out. So we take this 1 to the other side. So we have 2x equals 2. This becomes a negative. So 3 minus 1, which will give me a 2. Now I divide both sides by the coefficient, right? That cancels with that, leaving me x. That cancels with that, which is 1 over 1, which is 1. Okay? Let's say that's the answer that we get, and we want to check, is this correct? Because, guys, in maths, you can always check your answer and see if it is correct. Well, almost always. Let me not say always. So x equals to 1, that solves this equation. All that we have to do now to check is substitute x equals to 1 into our initial equation and see if the left-hand side equals the right-hand side. Okay, so let's try it. We're going to put 1 for x. So we have 2 bracket 1 plus 1 equals 3. Does the left-hand side equal to the right-hand side? Well, let's check. 2 times 1 is 2 plus 1, that's 3. 3 equals to 3. Yes, 3 does equal to 3. That is correct. So that means our x equals to 1 was the correct answer. Okay, guys, so that is the checklist of solving pretty much most of the equations that we're going to come up with. Okay, so let's go to the exercise. So we're going to exercise 9.2. So the worked example, you guys can check out if you get stuck. So I want to go to exercise 9.2 and we're going to solve some equations. Again, I'm going to do a few of them for you and then you guys are going to do the rest. So if I look at this, I'll do a hard one for you that, well, not hard, but let's say C. So 1C. This is exercise 9.2 on page 85. So 4x plus 2 equals to 14. 4x plus 2 equals to 14. Right, so let's follow our checklist, right? Step 1, multiply out any brackets and add any like terms together. There's no brackets to multiply out. There's no like terms to add on either side. Okay, step 1 is done. Step 2, isolate the variable by adding additive inverse. Okay, so that is the variable. We want to isolate that. We want to get rid of this positive 2. So what I'm going to do is take it to the other side, and or you can think of it as adding negative 2 on both sides. Okay, so I'll get 4x equals to 14 minus 2, which is 4x equals to 12. Right, that is step 2. Step 3, divide both sides of the equation by the coefficient of the variable term. Coefficient of the variable term is 4. Divide both sides by 4 and simplify. 4 over 4 cancels, which will leave us with the x, which equals 2. 12 over 4 is 3. Okay, x equals to 3. Guys, remember, check your answer, all right? So let's check the answer. Let's substitute x equals to 3 into 4x plus 2 and see if it gives us 14. So we have 4 into 3 plus 2 equals to 14. Well, we can't say it equals to 14 yet. Let's work it out. 4 times 3 is 12, plus 2 is 14. Okay, 14 equals to 14. Yes. Okay. Right, guys, so that's how you solve and check your equation. So that is 1C, and let's look at G. Okay. G says 2 to the power of x equals to 32. Two to the power of x equals to 32. Right, guys, so when we have an x in the exponent, we need to in order to solve this question, we need to make sure that the base on each side is the same. So if the bases are the same, that means the exponents must also be the same. Okay, so that is the trick. So, and also the trick is to look at this 2 and think, what power of 2 gives me 32? Okay, so remember, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, and 2 to the 5 is 32. So I know 2 to the 5 is 32. So what I want to do is I want to write this 32 as a power of 2. So 2 to the x equals 2 to the 5. Now, because this 2 is the same as that 2, that x must equal to 5 because we have an equal sign over there. So we can say, therefore, x equals to 5. Now, guys, with this equation, you can't really follow the steps that they gave us in there, right? This isn't a normal equation. This is an exponential equation, and you guys must remember how to solve this. And the idea is that to make the bases the same. Okay. Right, number H is also a little bit tricky, so I want you to think about that one, see what you come up with. All right. Right, let's continue. Number 2, write and solve the equation that represents these word problems. Let x be the unknown value. All right, guys, so I'm going to do a few more of these. So I'll do one of each. So write and solve the equation that represents the word problem. So they want us to not only translate, they say that x is the unknown, and they want us to find x as well. Right, so let's do A. The sum of a number and 15 is 63. Find the number. So the unknown is x, so that's what we're going to use. So x plus 15 equals to 63. Okay, so remember how we were doing this with expressions. Now we're doing it with equations, and we're solving the equation. Okay, so guys, in maths, usually this is the hardest part, okay, because a lot of people will have a problem. They'll say, right, I need to work out this thing. I have so many apples and I need to do this, and I've got that many liters of paint. How do I do it? Right? They have everything going on in their head in terms of words, but what is the answer to this problem? So the idea is that you need to translate the words into maths and then solve for the unknown. Okay, that's essentially what we're doing. So let's solve this for x. So we already have the equation. Step 1 says multiply, brackets, add like terms. We don't have that. Now isolate the variable. So we need to get rid of this 15. I'm going to take it to the other side. So x equals 63 minus 15, which equals to 53. So it would be 48. Okay, so x equals to 48. Now we don't need step 3 and, well, not 4, but step 3 we don't need because there's no coefficient in front of x. The coefficient is 1, and that's what we want. Okay, so now what's left is only to check your answer. Well, 48 plus 15 is 63. We can check that by adding them. 48 plus 15 equals 8 plus 5 is 13. Carry the 1. That's 156. So we have 63, which is correct. Okay. Right, guys, I want you to do B and C, or actually B, C, D, and I'll do E for you, and you guys do F. All right, so let's look at E. Right, so a number multiplied by itself and then multiplied by itself again gives negative 64. Find the number. All right, so we have a number which is x. We multiply it by itself, and then we multiply it by itself again. That gives me a negative 64. All right, let's write that down. So we have a number x. We times it by x again, and times it by x again. Okay, and that gives us negative 64. Well, we know what to do with that. That's just x to the power of 3, which equals minus 64. Right, remember, we can never have a square of something which equals to a negative number. But we can have a negative number with a cube, Because if we have three negative numbers multiplied together, it will give us a negative. So -1 times -1 gives me +1. +1 times another -1 gives me a -1. So an odd number of powers multiplied by a negative would give you a negative answer. Okay, so when we notice that, that's fine. So we know our answer is going to be negative. The x, well, yeah, the unknown is going to be a negative number. What number is it going to be? Well, what do we do to get rid of that cube? We cube root both sides. Okay, so we cube root both sides like that. That cube root cancels with that cube, leaving us with just the x equals. Right? What is a cube root of 64? Remember, we dealt with the negative already. We know our answer is going to be a negative. Okay? What gives us 64 when we multiply what by what by what, which is the same thing? Well, it's 4. 4 times 4 is 16, times 4 gives me 64. So the answer here, x, is -4. Now to check this answer, multiply -4 times -4 will give me +16, times -4 will give me -64. Okay. Right, guys, the rest of the word problems are for you to do. You have answers in the back to check. If you get it wrong, try again. Try to figure out where you made the mistake, what is going on. Right, number 3, it says a rectangle is twice as long as its width as it is wide. Its perimeter is 108 centimeters. Right, and the question says, what is its width? Calculate the area of the rectangle. Right, now with all of these problems, the idea here is for you to construct an equation. An equation with some of the variables that we don't know and some of the variables that, or not variables, but constants that we do know. So think about the info that they're getting us. They're telling us that the perimeter is 108 centimeters, okay? So can we get an equation for perimeter, put in the values that they give us, 2x and x, and that will equal to 108 centimeters? Well, the answer is yes. That's exactly what we have to do. So once we do that, we can solve for the unknown. So the idea is to take the information with the unknown and put it into equation with some numbers so that you can solve for the unknown. Okay, and usually the idea here is that there's some formula that you need to use or think of when you are solving these questions. Okay, so the formula that we're thinking about here is the perimeter formula. Okay. So let's say we have a rectangle like that, and they tell us that it is 2x and x. What is x? We don't know. Okay. The perimeter equals to 2 times length plus 2 times breadth. Okay, well, what is that? It's 2. Length is 2x. So when we substitute for something, put it into brackets. Even though it's still a variable, it still goes into brackets because we're substituting for length. Plus 2 breadth is x. Okay, so let's multiply this out. So we get, well, actually, no, let's not multiply it out yet. So this is the expression for the perimeter given the rectangle that we have. But they also told us that the perimeter of this particular rectangle is 108 centimeters. Okay, well, do you see this P is the same P? It's the perimeter of that shape. But here it equals to that, here it equals to that. So we can equate the two. So 2 times 2x will give me 4x plus 2 times x is 2x equals to 108. And this is my equation that I need to solve in order to get the x, which will tell me what is the width because the width is the x. Okay, let's solve this using our knowledge of solving equations. Add like terms. We've already multiplied our brackets. Now we're adding like terms. 4x plus 2x gives me 6x, which equals to 108. Right, now we need to step 3. We need to divide by the same coefficient. So divide by 6, divide by 6. That cancels with that. We have x, which equals 2. 108 divided by 6 is 60 is 10, 48 divided by 6 is 8, so this is 18. Okay, x is 18 what? Centimeters. Because if the perimeter is in centimeters, that means our distances are also in centimeters. So A, what is the width? It's 18 centimeters. B, calculate the area of the rectangle. Well, no problem. If this is 18, well, 2x is going to be what? Well, multiply by 2, it will be 36 centimeters. Okay. What is the area of rectangle? It is length times breadth, which equals to 18 times 36. Whatever that answer is, the units is centimeters squared. Okay, I don't have a calculator. You guys can multiply that. All right, so that is number 3. Guys, I want you to try number 4. So number 4 is very similar to 3. It's just that now we're dealing with a cube rather than a rectangle. Now the volume of a cube is length times breadth times height. Okay. And number 5, you guys can try to figure that out, make an equation, solve for the unknown. All right, so for this lesson, what I want you to do is exercise 9.2, whatever I haven't done with you. And I want you to do the revision section for the weekend, and we'll go over it next week when I speak to you via Skype. Okay, so the revision is on page 87. So please get it done for next week. And then that will take us to the next section, which is construction of geometric figures. Okay. All right, guys, thank you very much. I hope you enjoyed the lesson, and I'll see you next time.